Alright, welcome to your flipped classroom. So we've been talking a lot in the last week or two about the spheres of the Earth. And I'm sure that you're sick of talking about the spheres, so we're going to move on to something new, but we're still going to be referring to those spheres a lot. What we're moving on to, though, is chemical cycles. And I'm sure that you're familiar with the first cycle we're going to talk about, just as an introduction to chemical cycles, and that's what this image is showing. And hopefully you guessed this by now, that's the water cycle. We're going to talk through it, though.
So if you remember from the water cycle, we're going to start here at our A arrow, and what is happening is evaporation. So water is moving from its liquid state to its gaseous state as it's moving out of the ocean and into the air. Then what happens when it gets up into the atmosphere is it begins to cool, and condensation occurs. So it's moving from the gas state back to its liquid state. Clouds form, and once those clouds form, then precipitation happens in the form of rain or snow. And this precipitation comes down back to the earth, and a couple of things can happen once it hits the ground. It can either soak down into the ground, called infiltration. There enters the water table, and it can flow underground. Or it can run across the surface of the earth, which is called runoff, and through the streams and back into the lakes and oceans. So the water is making a complete cycle all the way through from the oceans back up into the atmosphere, through the geosphere, and of course the biosphere is impacted as well.
Alright, so the water cycle is a chemical cycle. That's because water is a chemical molecule. You can see on this image on the left the structure of the molecule water, with the oxygen atom in the middle and the two hydrogen atoms, one on either side of it. And the cycle part of it is because of the movement between spheres, and Ms. Zegers was talking about. She talked about water in the atmosphere, water in the geosphere when it came down in its precipitation and soaked into the ground. It also ran over the pedosphere, right? And then she did talk about the biosphere and how plants and animals all interact with water. And of course, the hydrosphere is involved because it's water, right?
So another chemical cycle that we're going to talk about is the carbon cycle. Now, what is carbon? Carbon is part of molecules that are very common in all of the Earth's spheres. There's movement of carbon between the spheres in what we call the carbon cycle, of course. Now, carbon dioxide is your main gas form with carbon in it, and this is occurring in the atmosphere at different levels depending on what interactions are going on. The carbon dioxide molecule has the carbon atom in the middle, and on the picture you can see that this carbon atom is this black color, and there's two oxygen atoms hooked to the ends. And this is kind of a similar structure to water, although water has the oxygen in the middle and the two hydrogens at the end. So we're going to talk about carbon a lot, and it's going to cycle through the different spheres in different forms.
Yep. So as we go and look at it in its different forms and different spheres, keep looking at it for the black atom, black carbon atom. Alright, so Ms. Zegers is talking about the molecule carbon dioxide, and that is, like she said, the gas form of it. It's a really common gas in our atmosphere. So most of the carbon that's in our atmosphere is carbon dioxide. And we know that it interacts with plants and people, that we breathe it out, the plants take it in. But one of the major ways that carbon dioxide gets into the atmosphere is through burning. So we have a picture here of a forest fire. And in that smoke, there's a lot of carbon dioxide, carbon going up into our atmosphere. Another form that carbon takes when it goes into the atmosphere is methane. It's just a different type of gas, but instead of mostly coming from plants, like carbon dioxide does, methane mostly comes from animals. So we have a picture here of a bunch of cows out on a feedlot. Those cows, they give off methane gas.
So how about the hydrosphere? Is there carbon in water in the hydrosphere? A lot of times we don't think about that as a possibility. But of course, carbon is able to enter the hydrosphere. carbon dioxide will dissolve into ocean water. And this happens when the waves are moving that water along the interface between the water and the atmosphere, and the carbon dioxide molecules that are in the atmosphere are being pulled into the water where they dissolve. You can see at the bottom here we have a water molecule, and then when you add it to the carbon dioxide molecule from the atmosphere, the carbonic acid molecule is what happens when those two molecules combine within the ocean.
Alright, and that's all carbon dioxide being drawn down into the water from wave action. Don't think about that wave action too much or you'll get seasick. And now carbon in the geosphere.
So we think about carbon going from the hydrosphere into the geosphere. And how does that occur? Well, carbon in the ocean comes out of the water as sediment and then forms limestone. Now, sediment happens as particles actually settle to the bottom of the ocean and they get really compacted into this rock, limestone. Limestone has a bunch of carbon in it, and it is a very common rock. In fact, it is right under our feet right now.
Oh, you can't see it, but it's down there. So, it's hard to imagine how carbon would get from water into rocks. But when we look at a rock like this limestone, you're actually seeing a lot of carbon. If you had a really high-powered microscope, you could see all of the molecules that make up limestone. And look, there again is our black carbon atom. It's in there, but it's with a bunch of green and red stuff. So we're going to take a step back and look at the molecule carbonic acid. Remember, this is what carbon is like when it is dissolved into the ocean, when it's in the water. And if we popped off these two hydrogens that are around it, what we have is a black carbon atom in the middle and 3 oxygen atoms around it. So this looks pretty similar to how that molecule looks in limestone. Again, we have that same black carbon atom with 3 oxygens around it. That's called a carbonate. And that is what makes up limestone. So that's how carbon gets from water, where it was dissolved as carbonic acid, into limestone, where it's a solid rock. And it's packed in there in the limestone with those green dots. Those green dots are calcium.
So let's talk about carbon in the biosphere. Carbon can exist in many forms in the biosphere. It is an essential part of all living things, and it's a building block for what we call carbohydrates, which are sugars. So, when we think about plants that photosynthesize, they're taking that carbon dioxide from the air and they're converting it with the energy from the sun into what we call glucose. And glucose is a sugar, and it's made up of these 6 carbons. You can see the carbons, the black carbons down in the middle of this sugar molecule. And once that sugar molecule is in there, it provides energy for the plant. Now, other animals can consume either the plants or they can consume other animals that have carbon within their bodies. And carbon is moving from one organism to another, and it can change forms within the body of the organisms as well.
Alright, so we've talked about carbon in the geosphere, in the atmosphere, in the hydrosphere, and in the biosphere. But to be a cycle, we have to be thinking about the transitions. So here's a little review of the transitions we've talked about. Ms. Zegers just talked about photosynthesis, which is carbon going from the atmosphere being taken into plants, turning into sugars, so it's joining the biosphere, right? Those plants are in the biosphere. Now, we also talked about ocean wave action, where the water in the ocean, in the hydrosphere, almost reaches up and grabs the carbon dioxide out of the atmosphere and pulls it down into the ocean, where it dissolves into carbonic acid. Then we talked about sedimentation, where that carbon that's in the hydrosphere as carbonic acid comes out and becomes solid again, and then it joins the geosphere by becoming limestone rock. We also talked about how carbon would get from the biosphere up into the atmosphere, either from burning and turning into carbon dioxide gas, or from being released as methane.
So as you can see, the carbon cycle is very much like the water cycle. And if you look at a picture like this, you should be able to trace that carbon as it goes from each sphere all the way around, and you can probably even label those arrows showing the interactions between the spheres and what forms of carbon move from which sphere to which the other sphere as they interact together.
Right, so just take a minute and look at this image, see what is new to you that you learned during this little presentation we've just given you, and what we didn't talk about that's also in this image that maybe you understand just based on some of the other things that we did talk about. And then you'll have a better understanding of the carbon cycle.